Hi, welcome to Python Polygon. Today I'll be starting a new playlist. It's the first one on the channel and it's going to be called Aptitude series. So basically what I'm going to do is I'm going to train you guys on aptitude and how to solve the questions and what you might see on the technical interviews and stuff like that. So basically if you break it down, aptitude comes down to nothing but simple mathematics and logic. Simple mathematics is something we've studied up to, we can say, till class 10. And logic is something like you don't study but you develop over time. So, yeah, and my aim is to upload a video every day starting from July 1st, and by the end of the month, you might be well versed at aptitude and you'll be able to solve good amount of questions. That's what I hope for. And I'll be sharing my thought process. I think of this as a friend teaching you something you don't know or you know a little weakly. Okay, so let's get started. Yeah, the first topic is going to be numbers. So, numbers are categorized in uh, many ways. One of the ways is based on their range. Okay, so based on their range, they can be categorized into these many categories. So firstly comes the smallest one. It's not national, sorry, it's natural. Here, there's a mistake. So it's basically natural numbers. Natural numbers are numbers starting from uh, not zero, numbers starting from 1, 2, 3, and so on. These are uh, numbers that go on till infinity. Okay, whole numbers are the next new set. It is basically 0, comma natural numbers. This can be written like this, and it also looks like 0, 1, 2, so on up to infinity. Next set is integers. What does integer do? Okay, see, it starts from negative infinity. Infinity is not a number, it's a concept. So basically, infinity is not something you can count. I guess you get the idea. So you start from minus infinity, you come all the way down to the minus 3, minus 2, minus 1, 0, 1, 2, 3, so on, and you go to positive infinity. So that is the range of integers. Next, the bigger set is called rational numbers. These numbers are represented in the form p by q, where p and q are integers. You guys might remember this, are integers, and q not equal to 0. So basically any number that can be represented in the form p by q where p and q are integers and q not equal to 0 is called a rational number. Okay. In this there are two categories of numbers that fall. Okay. One is numbers that terminate and another is it can be non-terminating. Okay. It can be non-terminating but it should be recurring. What does recurring mean? See, if there's a decimal point, say 7177 17717 so on. So this is a recurring decimal point where 717 is the repeating block. Okay, we can see it everywhere. So this can be written as, if this goes on till infinity, we can still call it a rational number. It can be written as 0.717 bar. Okay, so this is how you categorize rational numbers. The bigger set of this will be irrational numbers. So irrational numbers are numbers that are non-terminating and are non-recurring. Okay. Examples for irrational numbers are say 0.3125, 6, 5, 1, 2, 3, 4, 6, 7, 8, so on. Okay, some random numbers. Or very famous ones include Euclid's number, pi, and we can say, yeah, some other mathematical constants. Okay, so that comes under irrational numbers. Now, irrational numbers and rational numbers together make up real numbers. Okay, real numbers are any numbers that is rational plus irrational. Okay, but there is one category of number that does not fall into the category of real numbers. These are negative square roots. So negative square roots do not fall under real numbers. Where they fall under is called imaginary numbers. Uh, an example for an irrational number is root 3. An example for a rational number is 1 by 2. Example for integer, we have a lot of examples here itself, so I won't give you another example. So rational numbers are 1 by 2. We can even say root 49, which is 7. That's why it's rational, not because it's a root. And irrational numbers, you can say root 3, root 2, root 7, so on, where you can't predict. Real numbers are, uh, we can say root 7 minus 5, or root 6 minus root 5, so on. Okay. Imaginary numbers are a special kind of numbers where you are defining a special character called iota for negative square roots. Okay. Iota is equal to minus root of minus 1. So imaginary numbers look like a into I, where I is equal to root of minus 1. Okay. Uh, the set of real plus imaginary numbers make up the biggest number set known, which is called complex numbers. Okay. Complex numbers can be represented in the form a plus ib, where this is called the real part, this is called the imaginary part. Together they make up a complex number. Fine. With this knowledge, we can somehow continue. We have a good understanding of what number sets look like, and now we can continue. Okay, next comes prime numbers. Prime numbers and the opposite of prime numbers is composite numbers. Pardon my bad handwriting. Okay, prime numbers are any numbers which have factors of only one and the prime number itself. Okay, so the factors of the number are 1 and the prime number itself. An example for this is 2, where the factors of 2 is 1 and 2. 3, where the factors is 1 and 3. Okay, any such number which has 1 prime and some other factors, 1 to any number of factors, is called composite numbers. Okay, this includes 6, like 1, 2, 3, and 6 is their factors. 8, where 1, 2, 4, and 8 are factors, so on. So this is how it looks. And prime numbers, if I start listing, see, 1 is neither a prime nor a composite number. 0 also is neither a prime nor a composite number. These two cannot fall under the categories. Okay. So the numbers start from 2 and 3, and 4 is not prime, 5 is prime, 6 is not, 7 is prime, 9 is not prime, 11 is prime, 13, 17, 19, then comes 21 is not prime, 23 is prime, and so on. The list goes on, but these are very famous prime numbers. Okay, primes are very important for another thing called prime factorization. What is prime factorization? It is breaking down a number into its prime factors. Why this is important, we'll find out in the future, or you guys might already know. So yeah, suppose I have a number, say 64. If I want to break this into prime factors, what I do, I have to think about a smaller number that divides this number. So I know 2 divides this number. I'll divide it until I get a remainder 1. Okay, I'll keep dividing any kind of number, any kind of prime number only, until I get a remainder 1. So I am left with a number 32. If I divide it by 2 again, I get 16. Divide by 2, I get 8. 2 is the 4. 2 is the 2. And then 2 again is the 1. So I'm left with 1 here. I can stop here. And this is my prime factorization. 1, 2, 3, 4, 5, 6. So 64 can be written as 2 to the power 6. This is called a prime factorization. Similarly, I can do it for another number. Let's say 120. I can see clearly divides it is divisible by 2, so I'll divide by 2. I'll get 60. Again 2, I'll get 30. Again 2, I'll get 15. Now I see that I cannot divide by 2, so I go with the next number. So 3 divides. It goes 5 times and then 5 divides in the end and it goes 1 time. So 120 is 5 into 3 into 2 into 2 into 2. So this is 2 cube into 3 into 5. This is how you write prime factorization. Fine, we'll continue. Number system. So basically, the numbers we know and the numbers I've spoken about till now have all been in the decimal number system. Okay, that is, they have a base of 10. That is the digits 1, 0 to 9. These are the digits used in decimal number system. So similarly, you can have a binary number system where you use only two digits, 0 and 1. Similarly, you have octal where you use 0, 1, 2, 3, 4, 5, 6, and 7. 8 are there here basically, and you have hexadecimal, that is base 16. It starts from 0 all the way up to 10, not 10, sorry, right? And then 10 is represented by A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So this consists of 16 digits. So this is a little bit about number systems. So how can a number be converted from one number system to the other is, see, what you can do is, if say you have to convert the number 32 into binary, okay, you take 32 and you divide it by 2 and you note down the remainder here, okay. So 32 to the 16, and this goes 8 times, this goes 4 times, this goes 2 times, this goes 1. You get a remainder 1. So here the remainder was 0, here the remainder was 0, here the remainder was 0, here it is 0, and here it is 1. So this number can be written as 1, 0, 0, 0, 1, 2, 3, 4, 0, and another 0. So this is how 32 is written in binary. So whichever number you want to write, number system you want to write it in, divide by that number. If I wanted octal, I would divide by 8. If I wanted hexadecimal, I would divide by 16 and note down the remainder accordingly. Okay, fine. Now we go to LCM and HCF. So LCM is nothing but least common multiple. HCF, or you can also say GCD, is the greatest common divisor. What is the meaning of these two words? See, HCF of two numbers is equal to M means that this number M is the highest common factor. That means A can be written as some x into M, and B can be written as y into M again, okay, where x and y are co-prime. X and y are co-prime. Co-prime means they are prime with respect to each other. They don't need not be prime in real, but they are prime with respect to each other. So x and y are co-prime. M is the highest factor you can take common from here. So sorry, yeah, M is the highest factor you can take common. Hence we take it common, and that's what is the highest common factor. Okay, pretty self-explanatory. Now we go with the next one, LCM. LCM is the least common multiple. If this is n, it is the least common multiple of a and b. That means n divides a and n divides b. And this is the least possible case. Okay, this is the least number where n divides a and n is divisible by a and n is divisible by b. That is it for the theory part as such. And now we'll go for the problem. So, quick revision. Numbers are categorized into natural numbers, whole numbers, integers, rational numbers, real numbers, irrational numbers, complex numbers, imaginary numbers. Okay. Uh, there are prime and composite numbers too. There is something called a prime factorization which we'll be using in the future. There is number systems that can be, there are many number systems that can be used to represent the same number. There is something called a HCF and an LCM, and that's it. Okay. So we'll go to the problems. First question is, which of the following is not a prime number? Okay. To check if a number is prime, you have to divide every prime number from 1 to root of the number itself to check if it's prime. If it doesn't get divided by these numbers, then you can conclude that it's prime. Okay. So for option A, we start with the options obviously. So root of 43, we can approximate it to be 7 because root of 49 is 7 and we have to check till 7. Okay. So I will check 2 doesn't divide the number. 3 doesn't divide the number because the divisibility check of 3 is add the 2 and the sum should be divisible by 3. It doesn't work. 5 doesn't divide because it's not a 5 or a 0. 7 also doesn't divide, hence this number is a prime. It cannot not be a prime. Okay, so A is crossed out. Next there's B. B, you can evidently see that 5 plus 7 is 12, right? So 12 is divisible by 3, that means 57, the number 57 is divisible by 3. 3 ones are 3 and 27, 19s are. So we cross checked and 57 is not a prime, hence that's the answer. Easy question. Okay. Second question is the average of 4 consecutive odd numbers. Okay. Don't see consecutive and start writing a plus 1, a plus 2. Consecutive odd numbers is 16. Find the smallest of these numbers. See, always when we go for consecutive numbers, try to eliminate the uh, sum as much as possible. So by this, I mean start with a, okay, go one front and you'll get a plus 2 because a is odd, the next odd will be at a plus 2. Okay, similarly think one backward as a minus 2 because when you add these, a plus 2 and a minus 2 will cancel and a will remain. So plus 2 and minus 2 cancels, and the fourth number you can add anywhere in the either the left side or the right side. So I will go with the right side. I'll write it as a plus 4. Okay. Average of these numbers is 16. Average is defined as add all the numbers and divide by the number of numbers. That means I have to add a plus a minus 2 plus a plus 2 plus a plus 4 and I have to divide this whole thing by 4. This number is given to you as 16 in the question. Okay. You have to find the smallest of the numbers. We'll come to that. So you get 1a, 2a, 3a and 4a. So you get 4a plus 2 and minus 2 cancels, plus 4 remains. Plus 4 divided by 4 is equal to 16. 4 and 4 can cancel throughout. So you get a plus 1 equal to 15. 16. A is equal to 15. Okay, if A is equal to 15, which is the smallest in this series? The smallest is A minus 2. So the smallest number will be 13 in this series. That's the answer. Okay, this also was easy. Just if you start with A also, you can go A plus 2, A plus 4 and A plus 6. There's no harm in doing this. Just this one feels easier. Okay, and when the numbers become big, like if you say 40 consecutive odd numbers, then my trick will be very helpful. So keep that in mind. Okay, this also is very easy. Next, if the sum of two numbers is 30 and the sum of their squares is 85, see, always when they say uh, there are two numbers or there are three numbers, start with naming them. Okay, name them your favorite letters. I'll go with A and B. So I'll say A and B are my two numbers I need to find. Okay, sum of the two numbers is 13. So A plus B is 13. Sum of their squares is 85. So A square plus B square is equal to 85. Find these numbers is what we have to do. Okay. We know one thing. We can square on both the sides here. We'll get a plus b the whole square is equal to 13 square, that is 169. Okay. Now we expand a plus b the whole square. We get a square plus b square plus 2ab is equal to 169. But from this equation you get a square plus b square is 85. So I'll substitute it here. Okay. So I'll get 85 plus 2 into a into b equal to 169. So 2 into a into b is equal to 84. Okay. So a into b is 42. If a into b is 42 and a plus b is uh, a plus b is still 13, right? A into b is 42. Now we can guess the numbers. 6 into 7, right? And 6 plus 7 is 13. So that works, and both these are satisfied, right? So the answers are 6 and 7. Fine. Next question is the difference between two-digit number and the number obtained by interchanging the positions of the digits is 36. What is the difference between the two digits of the numbers? Okay, fine. Basically what it means is, see, they took a number. Let's say I will take a number 81. Okay, 81 they took. They reversed the digits and subtracted it like this. Okay, and then they got the number 36. Fine. So for the convenience of this question, I will take a and b as the number itself. Okay, where a is greater than b, because if b was greater than a, then the reverse would be more than the actual number. So assuming a is greater than b, a minus b, ab minus ba, this is not a into b and b into a, it is ab as a two-digit number and ba as a two-digit number is equal to 36. Okay, ab as a two-digit number can be written as 10 into a plus b, right? Because see, any two-digit number, say 81, this is nothing but 8 into 10 plus the units place, right? 1 into 1. Okay. Similarly, if I had a hundreds place also, I had to write this as plus 3 into 100. Okay, and so on. It goes forever. You can do it for how many places you want. So using this logic, we will evaluate the question. So 10 into a minus b plus b minus, this is nothing but 10 into b plus a is equal to 36. Now 10a plus b minus 10a minus 10b, sorry, minus a is equal to 36. So we get a and a, 9a minus 9b is equal to 36. So I can take 9 common. A minus b is equal to 9 times of this is equal to 36. Hence a minus b is equal to 4. This is the answer. This was a medium question. You need to know how to expand a two-digit number basically. Okay. What is the digits place in the product 267 to the power 153 into 66666 to the power 72? Okay, we need to understand something called a repeating block here. Whenever they say units place, we have to just analyze how the units place changes. So we'll catch the first term. It is 267 to the power 153. So let's see 267 to the power 1. The units place only we are worried about. So we say this units place is 7. 267 to the power 2 becomes 7 into 7. So that becomes 49 and 9 remains. 267 to the power 3 is 9 into 7, 63 and 3 remains. 267 to the power 4 is 3 into 7, that is 21 and 1 remains. Okay. 267 to the power 5, just to check, is 7 into 1 is 7. So this block seems to be repeating, and in fact it does repeat forever. So basically what we can say is 267 to the power n follows this fashion. Okay. Now, if we find which block this falls under, this number 153, we can clearly categorize it into wherever it is. Okay. So what we do for that is, uh, see, 267 to the power 1 is nothing but n mod 4. Mod means divided by 4. Okay. When n is divided by 4, it leaves a remainder 0, is how this equation is read. So this condition is nothing but n mod 4 is equal to 1. Okay. N mod 4 is equal to 1. This condition is n mod 4 is equal to 2. Why we take mod 4? Because the size of the repeating block is 4. So this is nothing but n mod 4 is congruent to 3, and here it is n mod 4 is not 4 but it is 0, because 4 cannot be a remainder. Okay, so now what we can say, that is, when 153 is divided by 4, depending on what remainder it leaves, we can categorize it as 7, 9, 3 or 1. Okay, so we try dividing. We get 3s are 12 and 3 remains 33, 8s are 32, and then 1 remains. So this is nothing but the 7 category. Hence, this whole thing can be replaced by one single 7. Okay, into. Similarly, we do it for 66666 to the power 72. We check for the repeating block in 6666 to the power 1 is 6. To the power 2 will be 6 itself, and that is a fact to be noted, is 6 to the power n will always end in 6. Okay, however, how many more times you multiply, regardless of what is there this side, anything 6 ending in 6 to the power n will end in 6. So we can eliminate this whole thing and write 6. So 6 into 7 will give you 42, which ends in a 2. So 2 is the answer. Okay. Seventh question. What? Okay, this question. What is the total number of prime factors in the expression 12 to the power 12 into 16 to the power 16 into 18 to the power 18? Okay, prime factors we know is a prime raised to any power. Okay, so basically we break all these bases into its prime factors. 12 is nothing but 2 square into 3. 16 is nothing but 2 to the power 4, and 18 is nothing but 2 into 3 square. Correct? So this, when you have to raise to the 12th power, this you have to raise to 16, this you have to raise to 18th power. Okay. From here it's clear that there are only two prime factors for the whole thing. You can see that it's either 2 or a 3. So we mark the answer 2. There are only two prime factors for the whole number. Whatever you get, n is equal to after multiplying this. Okay. This was a trick question, but it's pretty easy. Okay, Ethan. You are given a largest of 5 digit and you have to subtract x from that number. So that number is divisible by 23. Find the smallest possible value of x. To do this, we now check what is the largest 5 digit number. That is nothing but 99999 divided by 23. See how many times it goes. So basically we get this as, it goes 4347 times perfectly. So we multiply that number which it goes perfectly by 23. So we get 4347 into 23 as the closest value to the biggest number. So we get this as 99981. Okay. So this is the closest value to this number that is divisible by 23. So the value of x will be nothing but 99999 minus 99981. This comes as 8 and this is 1. So 18 is the answer. This was simple. Okay, next question. A number leaves remainders 1, 4 and 7 on being divided successively by 3, 5 and 8 respectively. Okay. So basically what they're saying is some number x, okay, when you divide it by 3, okay, it leaves the remainder 1. Then when you divide this quotient by 5, it leaves a remainder of 4 is what they're saying. And then when you divide this quotient when you divide it by 8, you get the remainder as 7. Okay, this is what they are saying. To solve this question, we go from the back. Okay, so they are saying that something when you divide it by 8, you're getting the remainder 7. So that has to be in the form 8 into 1. Okay, we'll catch the minimum case. So 8 into 1 plus 7. Okay, that is nothing but 15. Okay, so 15 when you divide by 8, you get the remainder 7. Yes, that works. So now we go backwards. I mean, we go forwards basically. So this number 15, when you divide it by 5, you get the remainder 4. Okay, so 15 times of 5 plus 4 should give you the next number. Okay, that 15 times of 5 is nothing but 75. 75 plus 4 is 79. Okay, so now you got this number. 79 when you divide by 5, you get remainder 4. 79 when you remove the numbers 4, you get 75. 75 when you again divided by 5, you get 15. So that quotient goes to the 8 part. Okay, so next you can go forward by 79 into 3 plus you get the remainder 1. So this is answer is 238. Now if the order of division is reversed, you have to start with 8, not end with 8. So basically you have 238, you divide it by 8, you get a remainder of what is the question. Now 238, it goes 2 times as 16, and then you have 78 left and 29 times 72, and 6 is the remainder. Okay, you have 29. You have to divide 29 by 5. You get a remainder of 4. And then you divide 5, the number which is left in the quotient, when you divide it by 5 basically, that number is 5. You divide this by 3 and you get the remainder as 2. So you multiply all these is what they're asking you to do. 2 into 4 is 8 and 8 into 6 is 48. So that's the answer. 48 is the answer. Next question. Three friends start running together on a circular track at 8 a.m. They started at 8 a.m. and time taken by them to complete one round is 15 minutes, 20 minutes, and 30 minutes respectively. Okay. If they start running continuously without any halts, then at what time will they meet again? For the fourth time. Okay. When will they meet for the first time is the LCM of these numbers, because the 15-minute guy has to finish the round. The 20-minute guy has to finish the round, and the 30-minute guy has to finish the round, and they have to meet at the same time. So it has to be a LCM question. Okay, the LCM of these numbers is 60, because 60 goes 2 times with 30, 3 times with 20, and 4 times with 15. Okay, so the LCM is nothing but 60. They meet again at 9 a.m. basically for the first time. Then they meet at 10 a.m. for the second time and 11 a.m. for the third time, 12 p.m. for the fourth time. So that's the answer. Okay, HCF of two numbers is 11 and their LCM is 385. If the numbers do not differ by more than 50, what is the sum of the two numbers? To solve this, this is a little tricky. We need to know one property that states the product of the two numbers is equal to their LCM into their HCF. Okay. Now that we know this, we now know that the two numbers do not differ by more than 50. Okay. By the question, we can understand that the HCF of the two numbers is 11. Okay. So A can be written as 11 into something and B can be written as 11 into something else. Okay. We'll call it 11M and 11N. Okay. We'll substitute back in this equation and we'll simplify and see what we can do with it. 11M into 11N is equal to LCM is nothing but 385 into HCF is nothing but 11. 111 and 111 can cancel. Another 11 and this can cancel. 3 times is 33 and 5, 35 times. So we're getting the numbers M into N is equal to 35. Okay, this is nothing but a m and n are integers. Hence, we can guess they're not integers. In fact, they're whole numbers. So we can guess the solution from here because 35 is nothing but 35 into 1, or it can be 1 into 35, or we can also write it as 7 into 5 or 5 into 7. So there are four possibilities for the values of m and n. Okay. Now, if the value of m is 35 and n is 1, okay, this will be 11 and this will be 385, where the difference of them should not be more than 50. Hence, this combination will not work. Okay. Hence, this combination has to work. Now, if they are telling that one number is 7, okay, A is equal to 11 into 7, that's what it means, and B is equal to 11 into 5. Okay, they're asking the sum of these two numbers. I can simply add it here only. I'll get 11 into sum of these two numbers, that is 12. So this comes as 132. That's the answer. Next question. What is the least number which is exactly divisible by 6, 12, 9, and 18? Okay. This is nothing but an LCM question. Okay. Least number divisible by given numbers. How do we do this? We simply find prime factorization. 6 is 2 into 3. 12 is 2 square into 3. 9 is 3 square. And 18 is 2 into 3 square. So first we find the largest power of 2. It is 2 square. We write that in the LCM column. So LCM is nothing but 2 square into 3 square because 3 square is the highest power here. So the LCM comes as 36. That's the answer. Simple. Okay. The next question is A, B, and C start at the same time in the same direction to run around a circular track. A completes the round in 252 seconds. B completes the round in 308 seconds. Okay, and C completes the round in 198 seconds. Okay, all starting at the same point. When will they meet again at the point? This is nothing but the same type of question which we did when they start at 9 o'clock. So basically, what we do here is we convert this. No, instead of converting, you can simply just take the LCM of these numbers. The LCM of these numbers will be the time they meet again. Okay, so the LCM of 252. Okay, so basically the LCM of these three numbers comes as 2772. Okay, 2772. So they meet at the same point after 2772 seconds. Okay, this needs to be converted into minutes to match the answers. Okay, to do the same, we have to divide it by 60. So 200 and 2772, we have to divide it by 60. You get 46 whole minutes. Okay, 46 whole minutes plus 12 seconds as the answer. Okay, how we found the LCM of this is you prime factorize this, prime factorize this, prime factorize this, then do that method. Take the highest power in each variable and write the answer as LCM. Okay, so the answer comes as 46 minutes and 12 seconds after they start, they meet again. Okay, next question. Raymond wants to cut a rectangular board into identical square pieces. If the board is 18 inches by 30 inches, what is the least number of square pieces he can cut without wasting any of the board? To understand this, we'll draw the board. If the board is 30 inches by length and 18 inches by breadth, so if a square piece comes like this, it should be divisible by 18 and it should be divisible by 30, right? So 18, A should divide 18 and A should divide 30. This is nothing but the HCF, right? So for the square length to be maximum, we find HCF of 18 and 30. 18 is 2 into 3 square and 30 is 3 into 2 into 5. So we see that 6 is common in both places. HCF is 6. Hence, number of pieces he should cut it into is area of the larger square, area of the larger rectangle divided by area of the smaller squares. Okay. Area of the larger rectangle is 18 into 30. Area of the smaller square is 6 into 6. So you get this answer as 15. So he cuts the pieces in the board into 15 pieces. That's the answer. The last question is how many trailing zeros are in 64 to the power 7 into 125 to the power 7? Okay. A number 64 to the power 7 into 125 to the power 7 is given to you. Okay. So to understand what a trailing zero is, we need to understand how it is created. Okay. By the way, trailing zero is nothing but some number and then it ends in zeros. These three are called trailing zeros. Okay, it ends in zeros. So the number of zeros on the left side of the decimal point is called trailing zero. Okay, until you encounter some character after that. Anyways, now let's see how to find out what makes a trailing zero. Okay, see, we can write the number of trailing zeros. This number is divisible by 1000, right? So that means then a trailing zero is created when a 10 is there in the factor. So to find the number of tens, we need to find the powers of 2 and the powers of 5 and take the minimum, because the minimum number of 2's and minimum number of 5's will interact and form a 10 and form a trailing zero. Okay, so 64 is nothing but 2 power 6, 2 to the power 6 to the power 7, and 125 is 5 cube power 7. This comes as 2 to the power 42 into 5 to the power 21. Okay. So now what we do is we have to take the minimum degree, because the minimum number of tens will be created, not the power of the maximum. So this can be written as 10 to the power 21 into 2 to the power 21. Okay. So there are 21 trailing zeros in this whole number. That's all for this chapter. You can let me know your feedback in the comments, and I'll see you guys in the next chapter. Thank you.